In this problem, we want to test the claim that students living on campus gain the average 15 pounds at the end of their freshman year. So before you even start doing anything, anytime you're dealing with a problem where you're testing a claim, I always remind my students to write down on their paper next to the question the parameter that you are testing. So here we're testing the claim about some mean value. So the parameter is mu, where mu is the average weight gain. And then the next thing that you want to ask yourself is, do you know the population standard deviation or not? So in this problem, notice that the population standard deviation sigma is not given to us. So this is an unknown value. Anytime you're testing a claim about a mean value mu and sigma, or the population standard deviation, is unknown, you are always going to use the t-distribution, which means that we're going to use a t-test, okay? So when you're using a t-distribution, that t-distribution, it does look a lot like the normal distribution, but I'm going to exaggerate the tails here. On a t-distribution, the tails are a little bit wider, and every t-distribution is unique to the sample size. So here, since we have a sample of 125, the t-distribution that we're going to use is a distribution that has a degree of freedom of n minus 1. So 125 minus 1 gives us 124. At the center of this distribution is where we write our null hypothesis value, so mu naught. Okay, now we're ready to go through the hypothesis test, and we can break it down to a series of steps, where the first step is for us to write down the null and the alternative hypothesis. So step one, identify the null and the alternative hypothesis. In this particular problem, the claim is that students gain 15 pounds. So since that statement contains equality, has the equal sign, that's going to be the null hypothesis. So mu equals 15 pounds. I'm going to keep track that this is the original claim. So the original claim is the null hypothesis. This means that the alternative hypothesis is going to be that mu is not equal to 15. So since the alternative hypothesis has that not equal sign, this tells me that on the t-distribution, I'm going to do a two-tailed test. And what I'm marking right now is I'm marking my critical value, t sub alpha divided by 2 on the left. So that'll be a negative critical value. And on the right, that marking on the right will be t sub alpha divided by 2 on the right side. That critical value defines our critical region, which I'm shading in red. So the area I'm shading in red is separated by those two critical values. And the shaded area has an area that is half of our significance level. So in this problem, we're going to use a significance level of 5%, or 0.05. So I split that equally in both tails. So the area on the left tail has an area of 0.025, and the area on the right is 0.025. And again, that number 0.025 is just your significance level divided by 2. Okay, now what I'm going to do next before I go to the next step is I'm going to go ahead and try and calculate this critical value. And you can use your calculator for this. So on your calculator, to calculate the critical value, so this is typically considered step 3, okay, where step 2 is to calculate your test statistic. So let me go ahead and jump to step 3. Let's get our critical value. And in this problem, it will be critical values because we have a two-tailed test. So again, on your calculator, you can use inverse t here. So inverse t is going to ask you for the area to the left. So you can find the negative t-score in the left tail or the positive t-score in the right. Whichever one you want to find will determine what area you type in when you use inverse t. So I'm going to just find the positive critical value in the right tail by typing in 1 minus the area on the right. And then the next thing that you type in is your degrees of freedom. So 124, press enter. This will give us 1.98. So that means that this marking here has a critical value of 1.98 on the right tail, which means that on the left tail, this marking there, that's going to be negative 1.98. Okay, now we're ready to actually calculate the test statistic and then the p-value, and then make a decision about that null hypothesis. So to calculate a test statistic, we're going to need a formula that is a formula for a t-score or a t-value. And that formula involves some sample data. So let's take a look at our sample data here. We have a sample of 125 participants with an average of 2.7 pounds and a standard deviation of 6.4 pounds. So we need to figure out what that t-score is on this t-distribution on the right. So let's put everything into the formula. That formula is t is equal to x bar, so 2.7, minus the null hypothesis value, which is 15. Divide that by the sample standard deviation of 6.4. Divide that by the square root of our sample size. So I'm going to use parentheses here to make sure I put this into my calculator and maintain orders of operation. This will give us a t-score of negative 21.49, which is a very large t-score. Okay, that is very, very far away from the center of the distribution. So at the center of our distribution here, that's our mu naught value. We expect it to be 15 pounds. And our test statistic, which I'll mark in green here, I'm going to have to exaggerate the tails here because this is not drawn to scale by any means, but I hope you guys can kind of just see here. Again, I'm exaggerating this drawing here just so that you can see, all right, what the tails look like on both sides, all right? And if at the center the t-score is 0, my critical value, this marking here is negative 1.98. I don't even have enough space to draw this to scale, but I hope that you can see that my test statistic of negative 21.49 is very, very far in the left tail. Okay, so we probably already have an idea of what the p-value is, so that's step 4. The p-value is the probability that is associated with getting a test statistic that is at least as extreme as the one that we got. So on our graph, because this is a two-tailed test, our p-value is going to be the area that I'm about to shade in green here on the left, and also the area that I'm going to shade in green here on the right. So the p-value is the area that is to the left of our test statistic. And then I'm also going to mark the positive t-score on the right-hand side, so positive 21.49. So I can also mark the shaded region that represents the p-value, half of the p-value on the right. So the area that I'm shading in green on the left tail, that's half of your p-value, and then the other half is in the right tail. So the other half is in the right tail. So to find, and then again, the red shaded region also goes all the way out to the tail. Okay, so to calculate that p-value, we can also use the calculator function called tCDF. So again, because we're on the t distribution, we're going to use tCDF, not normal CDF, because we're not on the normal distribution here. tCDF is going to ask you to put in a lower bound and an upper bound. So I'll use the left tail here, where the left bound will be a very large negative number. So I'll type in negative 1e99 and then go up to your test statistic of negative 21.49. Then put in the degree of freedom, which is 124. The answer that you get is going to be the p-value that's on the left tail. So whatever this answer is, don't forget that you have to multiply it times 2 so that you get the green shaded region in the left and the green shaded region in the right anytime you have a two-tailed test. But we also know that 0 times any number is just 0. So our p-value for this problem is a p-value of 0. All right, and that kind of makes sense because if you take a look at your test statistic, negative 21 is really far away from the center, which would have a t-value of 0. And then look at our critical value. So our critical value on the distribution, look at where I marked negative 1.98, right? Negative 1.98 is a little bit closer to 0 than negative 21.49 would be to 0. So because it's so far away from the center, the probability associated with it is going to be extremely small. So small in this case that it's actually 0. Okay, so now let's make a decision about the null hypothesis. So that's the next step, is to make a decision about the null hypothesis. Are we going to reject it, or are we going to fail to reject it? If you are using the critical value method, so the critical value method says if our test statistic falls in the critical region, we will reject the null hypothesis. Notice that our test statistic, which is this thing that I'm marking in blue, it does fall in the critical region, which is the red shaded region on the left tail. So because it falls in the critical region, we would reject the null hypothesis, okay? If you're using the p-value method, you can see that the green shaded region on the left and the right when we add them together. The green shaded region is less than the total of the red shaded region in both the left and the right tail. So here we would also reject the null hypothesis because the p-value is less than our significance level. So I will write down the reasoning off of the p-value method. So I'll say since the p-value is less than our significance level, right? In other words, 0 is less than 0.05, we're going to reject the null hypothesis. And again, you can use the critical value method or the p-value method. It will lead to the same conclusion about the null hypothesis. So then now we're ready to interpret our results and address the original claim. So don't forget that up here, we rejected this, okay? All right. But also, what we reject is also the original claim, and it sits in the null hypothesis. So the way that you would word your final conclusion is you would say that there is sufficient evidence to warrant rejection of the claim. Okay, so instead of saying to warrant rejection of the null hypothesis, let's actually write down what the null hypothesis is. So there's sufficient evidence to warrant the rejection of the claim that freshman students, I'll just write freshman students gain an average of 15 pounds. Okay. And you can elaborate on your conclusion here. You can even elaborate and say, in fact, the data suggests that on average, students probably gain somewhere closer to 2.7, or we can just round that up to 3 pounds, nowhere close to the mythical 15 pounds. Okay, so I hope that that helps. Watch the next video. I'm not going to go through all of these steps like I did in this video, but I'll just show you how to use the calculator to get your test statistic value and your p-value.